Hey, there's Geometry, Unit 4, CP1, Lesson 4. Our objectives for today, as you can see, are to calculate the measure of each interior angle of a regular polygon, as well as the sum of the measures of the exterior angles. Let's get started. Okay, here I've got a regular polygon, specifically a pentagon, and a non-regular pentagon. Now, what we've studied in lessons past is that we can find each of these angles, which will be congruent. Since it is a regular pentagon, we can take n minus 2 times 180 and divide by n. That'll give us the measure of angle, let's call it x. Okay, so n, of course, is our number of sides, so that'd be 5. So 5 minus 2 is 3. 3 times 180 divided by 5 comes out to equal 108 degrees. So each of these red angles are 108 degrees. That means that each of the blue angles, which are also all the same measure, will be 72. Now, if I were to add up all of those exterior angles, what I get is 360 degrees. Now, this is special, right? Because this is a regular pentagon. So would it be any different if we had a non-regular pentagon as shown in the diagram to the right? So we've got pentagon FGHKL. And we've got each of these measures, right? We got 122, 133, 94, 96, and then some unknown angle measure x. So let's find that angle measure. Now, in a pentagon, I know that the sum of the interior angles will be n minus 2 times 180. So I know that these 5 angles should add up to 540 degrees. So 540 degrees, of course, would equal the sum of the following angles: 96, 94, 133, one running out of room, 122, and x. If I were to add up these 4 angles, I end up getting 445 degrees. Now, adding that to our unknown angle x should give us a total sum of 540. Okay, so let's find the measure of angle x. Subtracting 540 minus 445, we get 95. So x should equal 95. Now, why did we find x? We found x so that we could find each of the exterior angles. So 95 and f are going to be supplementary or form a linear pair. Therefore, f would have to be 85. So f is 85. G is going to be supplementary with 133. So G will be 47. H will be supplementary with 94. That'll mean H is 86. K is going to be supplementary with 96. That means K will be 84. And L will be supplementary with 122, which will mean that L is 58. And I forgot K, poor K, special K, jokes. All right, so if I were to add up these 5 angles, I would also see that I get 360 degrees. So the sum of the exterior angles of any polygon is going to be 360 degrees. That's regardless of number of sides. That's regardless of regular or non-regular. All right, let's look at the formulas we've accumulated to this point. All right, so we've got sum of the interior angles, n minus 2 times 180. Single interior angle measure. Of course, this is assuming that we've got an equiangular polygon, right? Or it could be referred to as regular. Okay, that'd be n minus 2 times 180 divided by the number of sides n. For exterior angles, we know that the sum of the exterior angles will always be 360. And we can find a single exterior angle measure by taking 360 divided by n, again, assuming this equiangular property within the polygon. All right, let's use these in a few examples. All right, number 1, find out how many sides a regular polygon has if each exterior angle is 36. So a single exterior angle measure is 36 degrees. Now we know we can find a single exterior angle measure by taking 360 divided by n, provided that it's regular or equiangular. Therefore, in this case, I could find n by dividing multiplying both sides by n. I can do that right here. And then dividing both sides by 36. So it looks like n is 10-sided. Okay, which would mean we've got a decagon. Now this would be a regular decagon, of course, in this scenario. All right, example 2. How many sides does a regular polygon have if each interior angle is 168? Now I see interior, and so I think of my formula, n minus 2 times 180 divided by n. Now I know that that's equivalent to 168 degrees, right? That's what I'm told. If each interior angle of a regular polygon is 168. Now in this case, I'm going to isolate n in a very peculiar way. I'm going to multiply both sides by n. So I get n minus 2 times 180 is equal to 168n. Okay, I'm going to distribute 180 to both the n and to the 2. That gives me 180n minus 360 is equal to 168n. Now, this is where a little bit of work comes in. I'm going to subtract a little bit more work, at least. 180 from both sides. I'm going to keep the n attached. Those are like terms. Okay, common mistake. This is not true. Is to say that this is, which it's not, but to say that this is equal to negative 180n. It's not. Notice they are not like terms because 360 does not have an n attached, so be careful. All right, so I'm going to get negative 360 is equal to negative 12n. I'm going to divide both sides by 12. Negative 12. All right, now how many times does 12 go into 36? Goes in 3 times. Therefore, it goes in 30 times to 360. So we'd have a 30-sided polygon. All right, let's take a look at example 3. Calculate the measure of angles C and D. And I'm going to add round to the nearest whole number. Just a reminder that you can do these problems, pause the video at any time. Okay, so in order to find that, what I want to find here is I want to find this angle x. Notice all of these angles will be the same. So I'm going to use my single interior angle formula. So I'm going to find this single interior angle, which I'm going to call x, of this, let's count the sides, 1, 2, 3, 4, 5, 6, 7. 7-sided polygon, which is called a heptagon. 7 minus 2 times 180, divide by 7. That's 5 times 180, divided by 7. Which I'm going to round to 129 degrees. I'm rounding. I believe it was 128.57 and some change. I'm rounding that to 129. Okay, so each of these angles are 129 degrees. So that's helpful, right? Because then what it tells me is that angle C and 129 are supplementary. Therefore, angle C should be 51 degrees. 51 degrees. Let's find angle D. Now, let me kind of zoom in on this scenario here, where here is angle D. I'm going to just focus on that specifically here. Notice how this angle here and that angle there are the same. and this angle here is x, which is 129 degrees. Now these three angles, I'm going to name this angle D. These three angles should add up to 360. So I should have 129 plus 2D is equal to 360. All right, you can see that if I added 129, this angle measurement here, plus 2 of these angles, which are going to be equal in measure, I'm calling them D, 2D is equal to 360. I'm going to subtract 129, which is 231, and divide by 2. So I get that D equals 115.5 degrees. All right, let's look at one more example on this slide here. Calculate the measure of angle B. Okay, so here's angle B. I'm going to do a little highlighting here. Notice that angle B is congruent to each of these three angles. So I'm going to call each of those angle B. Now, angle B added with 85 and with 43 and with this angle, those are all exterior angles of a non-regular polygon. So I could say that 3B plus 85 plus 43 plus this unknown number in yellow, which I can find in a moment, should add up to 360. All right, notice how I have the 3B here, which accumulates those three angles together. Okay, so I've got my three green angles, I got my 85-degree exterior angle, I've got my 43-degree exterior angle, and then this unknown angle, which of course will be 112 degrees, since 68 and 112 add up to 180. Okay, so 85, 43, and 112 add up to 240. And then of course I've got three angle B's, not 36, but 3B. I'm going to subtract 240 from both sides. So 3B equals 120. It looks like B, if I divide both sides by 3, will equal, how about 40 degrees. Okay, there we have it. B is 40 degrees. And you guys, that's lesson 4. Unit 4, lesson 4 complete. See you in lesson 5.